Hello, you are welcome. The question here says a stone is projected horizontally from the top of a vertical cliff 80-meter high with a velocity of 12 meters per second. Find A, the time taken to reach the ground. B, the velocity with which it hits the ground. And C, the horizontal distance covered from the foot of the cliff. Now, for us to solve this, let us start by taking note of this type of motion. Please, this is a very sensitive question under motion. So this is a case of horizontal projection. It is a case of horizontal projection where from the top of a cliff, an object is thrown horizontally with a velocity of u is equal to 12 meters per second. And then it has to fall down like this in this direction. So this is the question now. Don't forget we are given the height of the cliff. So that means the height of the cliff like this is 80 meter. So now in a question like this, please, I would like you to be very careful when handling question like this, because it is very, very important to take note of the fact that this initial velocity given does not affect the vertical motion of this object. Take note of that again. The initial velocity given here, this 12 meters per second, does not affect the vertical motion of this object. So as a result of that, we are taking this object as a free falling object where u is equal to 0. We are not using this u is equal to 12. We are using u is equal to 0. It is taken as a free fall motion because this u does not affect the vertical motion. Now, for us to solve this, to get the time, because the first question there says that we should find the time taken to reach the ground. So for us to calculate the time in this question, we are simply going to take the formula h is equal to half gt squared. So this is the formula we're going to apply in calculating the time. You can see this question is similar to the equation of motion that we have ut plus half gt squared. So because the u has been taken as 0, we have thrown away that part and we are now using only the half gt squared. So substituting values now, the height is 80 from the question. So the height of the cliff, which is 80, is equal to half multiplied by the value of g, which is 10. Acceleration to gravity is 10 multiplied by t squared. We are looking for the time. So 2 divided by 2 is 1. 10 divided by 2 is 5. So I have 80 is equal to 5 multiplied by t squared, and that is 5t squared. So to get the value of t squared now, I'm going to divide both sides by 5. I also divide this by 5. So that will now take me to the point where this cancels this and I'm left with t squared. So let me write the t squared first. And it's equal to 80 divided by 5 is 16. So from there, to get the value of t, I have to take the square root of both sides. So t will be equal to the square root of 16 because the square root of t squared is already t. And then finally, that will give us 4. The square root of 16 is 4. So the time is 4 seconds. So it takes 4 seconds for the stone to reach the ground. So that is question A solved already. Now let's move to the B part of the question. The B part of the question says we should find the velocity with which it hits the ground. That is the velocity with which the stone hits the ground. Similarly, this is also a vertical motion. And in this vertical motion, we are looking for velocity. So the right formula to apply here, which is still free fall formula, is v square is equal to 2gh. In this case, u square is 0. This is the formula for v square is equal to u square plus 2gh or 2gs. Now, the u square, which is the initial velocity, is 0. That is why we have thrown away that part and we are taking only 2gh. Please, like I said, don't forget, this value of u does not affect the vertical motion. So we are not using it for now. So v square, because we are looking for the velocity, is equal to 2 multiplied by g is 10. Acceleration of gravity, that is 10. Multiplied by the height, which is 80. And so that will give me v square is equal to 2 multiplied by 10 is 20. 20 multiplied by 80 will give us 1600. That is 1600. Now, for us to get the value of v, we are going to take the square root of both sides. So let me continue from here. Taking the square root of v square will give me v. And then I take the square root of 1600, that is square root of 1600, and that will give me 40. So that means the final velocity is 40 meters per second. So this is the final velocity of the stone on reaching the ground. Now let's look at the last question there. That is the C part of the question says, find the horizontal distance covered from the foot of the cliff. So if you look at this diagram, the question is asking us to find this horizontal distance. And I'll call it S. This horizontal distance is what is affected by this value of u. So it is when calculating this horizontal distance that we are to use the value of u. When we are dealing with the vertical motion, we don't use this u. We only use it when we are dealing with this horizontal motion, this horizontal distance. And so from there, I can say that horizontal distance S is given by the formula to find that S, that horizontal distance, is given by u multiplied by the time. So this is the formula to find that horizontal distance. And then the u from the question is 12. Don't forget, the velocity there, as you can see, is 12. So 12 meters per second. So this is the u that we are to use now. So 12 meters per second, and then that will multiply the time. We can see our time here is still looking at us. The time is 4 seconds. So this is the time. So 12 multiplied by 4. And that will give us that horizontal distance covered as 48 meters. And that is the final solution. Hope you enjoyed this video. Please don't forget to subscribe to this channel and also like and share this video so that others can learn from it. Thank you for watching.